One thing we didn't talk much about in class is something called a polynomial. And a polynomial is a collection of terms, and those terms have to have certain characteristics. Um, it's the sum or difference of terms where the exponents on the variables are whole numbers. So, for example, if you look in your book here on this page, it has f of x equals 3x squared minus 8x plus 9. Each term is separated by an addition or subtraction sign. So this example of a function has three terms. 3x squared is one term, negative 8x is another term, and positive 9 is another. So that polynomial has three terms. Now, there's something, a further explanation on what on the characteristics of something that of the terms that make it a polynomial. I want to go to a website called purplemath.com that gives some examples of terms that would not be in a polynomial. One example would be this term 6x to the negative second power. That if that term were in something that we were wondering if it was a polynomial, that would disqualify that expression from being a polynomial because the variable has a negative exponent. The other example of something that would disqualify an expression from being a polynomial, and that would be 1 over x squared or 1 over x cubed, or anything where there is a variable in the denominator. If there's a variable in the denominator, then that expression is not a polynomial. The square root of x, this is how you would see it in your calculator, but if you had the square root symbol of x in the terms that are listed there, then that would not be a polynomial because you can actually rewrite the square root of x as x to the 1/2 power, and that's true of any root. If you have the cube root, it would be x to the 1/3 power, and so on. So that would mean that that exponent of the variable is not a whole number, and therefore would disqualify that expression that would have the square root of x in it from being a polynomial. Again, terms are separated by addition and subtraction, and then the highest power, the term that has the highest power of the variable, the value of the exponent is the highest. In this case, is the term that is 4x squared, because x squared is the highest power of x. That's called the leading term, and typically in your textbooks and when you give answers, that you would want to order the terms in a polynomial from highest power to lowest. So in this case, 4x squared is the highest, because it's the first x to the second power, and then 3x is x to the first power, and then the constant term, the negative 7, that is technically called the 0-degree term, because 7 times x to the 0 power is just 7. That's one of the facts about exponents, is that anything to the 0 power is 1. So if we were to write 7x to the 0 power, 7 times x to the 0 power, then that would just be 7, because it would be equivalent to 7 times 1. Some examples here of the degree of a polynomial. The degree of the polynomial is would be the number of the highest power on the variable. So second degree polynomials examples would be like 4x squared, x squared minus 9. Third degree would be negative x times negative x 6x cubed, or x cubed minus 27, and so on. So these are examples of third, fourth, and fifth degrees. If your highest powered term was 15, then that would be a polynomial of 15th degree.